Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 1 to 5 of the June 2015 New York Regents exam for Geometry Common Core. All right, let's take a look at problem number 1. It reads, which object is formed when right triangle RST shown below is rotated about leg RS? Now, one tip you want to keep in mind when you're carrying out rotations is always making use of a sketch, okay? Always sketch the resulting solid that is generated by the rotation. These are the steps we are going to use for the problem solving process. First of all, we're going to identify our axis of rotation, and then we're going to sketch the resulting solid that happens when we rotate this right triangle about the axis. And then we'll apply our knowledge of geometric objects to identifying what object we have. Okay? All right, so this is the right triangle that we're looking at. Now what's happening is this is getting rotated about this leg RS. So in essence, this is our axis of rotation. So what kind of shape will we have, or object will we have, if we rotate this right triangle about this leg RS? Well, rather than guessing, let's go ahead and sketch what the situation looks like. So if this triangle is rotated about this axis, what's going to happen is that this is going to be like a circle right here. It's going to be kind of like a circle spinning around. Okay? And then we're going to have lateral sides like this. So this is one lateral side right there. And then that's the base radius. And then you have another lateral side. Well, this is a dotted line. So we can have another lateral side right here. And then another, well, with the radius. And then another lateral side right here. And then you have the radius. Now, what kind of shape is this? Because of our sketch, we can clearly see that we have a cone. Okay, so our answer to number 1 is option number 4. All right, let's take a look at problem number 2. It reads, the vertices of triangle JKL have coordinates 5, 1, -2, -3, and -4, 1. Under which transformation is the image J prime K prime L prime not congruent to triangle JKL? Now, one thing you want to note is that congruency is preserved under isometric transformations. Okay, so what type of transformations are isometries? The word isometry basically means all the measures are preserved. You have an isometric transformation whenever you're dealing with reflection, translation, or rotation. Okay, if you have a dilation, now that is not an isometry, so congruency is not preserved. All right, so remember, congruency just basically means the same dimensions. That's the fancy word for the same dimensions, congruency. All right, so the steps are as follows. First of all, we are going to identify the transformations in each option, and then we'll select the one that's not an isometry, the one that changes the size of the original object. Okay, all right, so for option 1, we're dealing with a translation. Translation is just a slide. Option 2 is a rotation, rotation about an axis. 3 is a reflection, and 4 is a dilation. Now, out of these 4, which of these is not an isometry? Remember, we talked about it earlier. Reflections, translations, or rotations are isometries, but dilations are not. Okay, so option number 1 is a translation. That is an isometry. Option 2 is a rotation. That's an isometry also. It doesn't change the size of the object. Option 3 is a reflection. That is an isometry. Option 4 is not an isometry because it's a dilation. The word dilate means to either increase in size or decrease in size. When you dilate an object by a certain factor, namely a factor of 2, every measure of triangle JKL will be doubled. Hence, J prime, K prime, L prime will not be congruent to JKL. because dilation is not an isometry. Okay, so our answer is option number 4. All right, let's take a look at problem number 3. It reads, the center of circle Q has coordinates 3, -2. If circle Q passes through 7, 1, point R, what is the length of its diameter? Now, one thing you want to note is that the distance formula used to compute the distance between 2 points on a coordinate plane is actually from the Pythagorean theorem. Okay, they're one and the same thing. All right, steps. First of all, we're going to draw a visual of the shape that we're dealing with here. We're going to find a length that represents the radius of circle Q, either using the distance formula or the Pythagorean theorem. Both of them work equally well because they're the same formulas in different forms. And lastly, we're going to use the radius to find the diameter. So be careful here. Remember, we asked to find the diameter. Some students might find the radius and find that it matches one of these options here and select it, not paying attention to the fact that the problem asks for the diameter, not the radius. Okay, so be careful. All right, so let's go ahead and sketch the situation we're dealing with here. So let's see. The points we have are in quadrants 4 and quadrant 1. So let's start with, it says the center is on 3, -2. So 1, 2, 3, 3, -2, 1, 2. So there goes the center of your circle. And then we know that a circle goes through 0.71. Okay, so this is the, let's see, let's call this O. Okay, and then 7, 1, or let's just call it Q. All right, so 7, 1, we have 3, 4, 5, 6, 7, 1. All right, so this segment, what is this segment right here? This segment is the radius of the circle, okay? So let's go ahead and sketch what the circle looks like. It's always good to give yourself a visual so you do not, so you can really understand what's going on. So there goes my nice little circle right there. And this is our radius R. This length is R, okay? Okay, so based on the coordinates, we can draw a right triangle here, right? So if I draw a right triangle here, what are the values, what is the length of my legs? Okay, since this is a right triangle, this leg right here is 1, 2, 3, 4. This is 4 units. This is 1, 2, 3. And I need to find R. Can I use Pythagorean theorem here? Absolutely, because we have a right triangle given 2 sides. If you know your Pythagorean triples, you know that the radius R is equal to 5 because this is a 3, 4, 5 right triangle. If R is 5, diameter is twice the radius. Since the radius is 5, we double 5 and get 10. Our answer for number 3 is 3. Okay? Now, let's assume that you do not know your Pythagorean triples. If you want to find this using the Pythagorean theorem, we call this A, B, and C. The longest side is always C, and A and B are the 2 legs. It does not matter what order you use. Okay, so you have A squared plus B squared equals C squared. A is 4 squared plus B is 3 squared equals C squared is R squared. So we just look for R, okay? So 4 squared is 16 plus 9 equals R squared. R squared is equal to 25. You take the square root of both sides, and then that gives you the value of the radius, which is 5 units. Okay, and that's what we got before. Now, let's assume that you don't want to use the Pythagorean theorem, or you like making use of the distance formula. You can use the distance formula here also. Okay, so the distance formula, remember, it's D equals the square root of x2 minus x1 square. All right, that's equivalent to a square plus y2 minus y1 square. That's equivalent to b square. Okay? All right, so all you just need to do is find x1, y1, x2, y2, plug it in here, and you're good to go. All right, so let's see what we have here. Let's call this point 1. This is our point 1, and in this point here, r is 2. Okay, so from Q1 is, what's the coordinate again? It's 3, negative 2. And that is equal to x1, y1. And then point R2 is 7, 1. That is going to be x2, y2. Okay, so we have everything we need to plug into our distance formula. x1 is 3, x2 is 7, y1 is negative 2, and y2 is 1. All right, so we go through all this trouble if we don't know the shortcut of using the Pythagorean theorem, but this is fine too. Okay, all right, so let's find the distance, which is equivalent to our radius. Is going to be the square root. Now, whenever you're making use of formulas, you always want to use parentheses. Okay, it's for your protection. So we have x2. Let's see, x2 and x1 are both positive, so x2 is 7 minus x1, 3 square, plus y2 is positive 1 minus y1, which is negative 2 square also. All right, so let's go ahead and simplify this. So we have r equals the square root of 7 minus 3, which is 4 square, plus 1 minus times minus is plus, which is 3 square. Wait for a minute. Do you remember seeing this anywhere? Absolutely. See right here, 4 squared plus 3 squared. Remember we stated earlier that the distance formula and the Pythagorean theorem are the same thing, they just look different. Okay? All right, so let's keep on going. So we have the square root of 4 squared is 16, plus 3 squared is 9, square root of 25 is equal to 5. So that is the radius. If the radius is 5, then that means the diameter is twice that, which is equal to 10. So we are confident that our answer is in fact option number 3. All right, let's take a look at problem 4. It reads, in the diagram below, congruent figures 1, 2, and 3 are drawn. Okay, so these are all the 2 transformations are isometries. So the question is, which sequence of transformations maps figure 1 onto figure 2, and then figure 2 onto figure 3. Now, one warning that you want to keep in mind is not really applicable here, but it's very important, is that whenever you're working on transformations, always pay close attention to the orientation of the vertices. Okay, so if you look at the figures we have A, B, C, D, E, F in a clockwise orientation. In figure 2, A, B, C, D, E, F in a clockwise orientation. And then figure 3, A, B, C, D, E, F in a clockwise orientation. All right, sometimes there might be some transformations that result in the reversal of orientations. If you are not paying attention to the orientation of the vertices, you might omit or skip that detail and get the transformation incorrect. Okay, so please always keep track of the orientation of objects when you're carrying out transformations. All right, steps 1 and 1. First of all, we'll determine what transformation takes you from figure 1 to figure 2, and then what transformation takes you from 2 to 3. Okay? All right, so from 1 to 2, what's happening here? We can clearly see that it's just a slide. Okay? Figure 1 was you just had to slide it right there. That takes you to figure 2. It's just a slide. So let's call it T1, transformation 1 is a slide. What is a slide? What kind of transformation is that? A slide is a translation. Okay, so the formal term for slide is a translation. Okay, now let's take a look at figure 3. From 2 to 3, is it just a slide? The answer is no. If you notice, AD is oriented north-south, north-south in from 1 to 2. In translations, the orientation stays the same. But if you notice in figure 3, the orientation of AD, the north-south orientation, has been rotated to east-west. Okay, so what kind of transformation causes that to happen? You have a rotation. Okay, it's like it's spinning around an axis. Okay, so whenever you have some kind of rotation, that's what the transformation is. So transformation 2 is a rotation. All right, so we have translation first and rotation second. So let's see which one our answer is. Remember, the order is important. You can't switch the order of composite transformations, or else you get a different result. Okay, so which one has translation first? Nope. Nope. Well, we have two candidates. Translation first. What was the second transformation? Rotation. Which one has rotation second? Option 4. Okay, so answer for this problem is option number 4. All right, let's take a look at problem 5. It reads, as shown in the diagram below, the angle of elevation from a point on the ground, let's call that point. This is the point right here. Okay, from a point on the ground to the top of the tree is 34 degrees. There goes your angle of elevation. Okay, now if the point is 20 feet from the base of the tree, so this point, and this is the base of the tree, if it's 20 feet, what is the height of the tree to the nearest foot? Okay, so what on earth is that talking about? Height of the tree. This piece right here. What is that to the nearest foot? Okay, now did you notice what I did while I was reading the problem? I was actually applying the information from the problem on the figure. Okay, actually creating a situation that I can solve. It's always good to annotate your diagrams as much as possible so you can easily solve the problem. Now, one quick reminder is that whenever you're using SOHCAHTOA, you always want to label your triangle with reference to the given angle. In this case, 34 is our given angle. All right? Steps. We're going to label our triangle with reference to angle 34 first. And then we're going to use SOHCAHTOA, figure out the right ratio to use to set up an equation. And then we're going to solve for the unknown side, which is x. That is what we're looking for, the height of the tree. Okay, so when I say label, what do I mean? Well, in SOHCAHTOA, we have opposite, hypotenuse, and adjacent. In this triangle, where's the opposite, where's the hypotenuse, where's the adjacent? Well, we have to go back to the reminder. Always label with reference to your given angle. So if this is the angle, this is what you're going to use to label your triangle, okay? The most important one that can easily get confused is the opposite, okay? So wherever the angle is, the side opposite that angle is your opposite, okay? So always label your opposite first. Why do I say that? Because the hypotenuse is normally easy to figure out. How do you find your hypotenuse? The hypotenuse is always opposite the 90-degree angle. Okay, whatever the 90-degree angle is, the side opposite it is the hypotenuse. Hard to miss. And then the other side is the adjacent. Okay? All right, so that goes the adjacent right there. Okay, now let's go ahead and solve the problem. I'll move my adjacent a little bit to the left so we don't get this confused. So there goes my adjacent, A. Okay, now what ratio are we going to use? Well, we're going to pick the ratio that involves the side we know and the side we need. Okay, we know the adjacent and we need the opposite. OA, OA, OA. So which ratio in SOHCAHTOA has O and A? It's TOA, right? So that tells us to use which trig ratio. We're going to use tan, the trig function tan theta equals opposite over adjacent. That is what TOA means, right? Okay, so let's see. Let's apply TOA to this triangle. We have tan theta, which is 35 degrees, is equal to the opposite, which is x, over the adjacent, which is 20. To isolate x, multiply both sides by 20. It's just as though you're solving a trigonometric equation. Okay? All right, so that cancels out. And you have x equals 20 tan 35. Let's use our calculator to figure this out. So what is the value of 20 tan 35? Now, the angle, why did I write 35? It's 34. Changing things for no reason. Sorry about that. Substitute 34. Okay, so what is the measure of our angle? Is it radians or degrees? It is in degrees. So we have to go to mode and ensure that our angle is in the right unit, or else it will give us the wrong answer. So make sure degree is selected or highlighted depending on what calculator you're using. So I selected degree, so 20 tan 34. Enter. Our answer is 13.49 to the nearest tenth of a foot. Let me write it down first, and then we'll do the rounding process. So 13. X is approximately 13.49017. So where is your tenths place? Just some elementary school math here. This is your 10th place right there. Okay, so if you want to round to your 10th place, since this is 5 or greater, you just carry 1 over and set everything else to 0. So you're going to have x is approximately 13.5 feet. Answer is option number 3. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found this tutorial beneficial to you, please give us a thumbs up. We'll appreciate your positive feedback. Don't forget to subscribe to this channel so you can get updates to the remainder of this review series. If you have any questions about the problems in this installment, or any questions on the Geometry Common Core Regents exam, just post a question in the comment section below, and we'll be glad to address it as soon as possible. Don't forget to try out our interactive practice tests where you work on released Geometry Regents exam questions to sharpen your skills. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day.